So hello there, we are team IoT Innovators and our problem statement is video call intercom based on analog/IP system with a vibration sensor and a motor. Okay, so our idea or approach to this solving this problem is we would have a device which will be present on every desk, and the device will have a video connection between all the clients. So I can make a video call to any of the client sitting at any of the desk with a live sign language converter. So suppose if I am a mute person or a deaf person and I can communicate verbally, so I can just do hand gestures. That video will be captured and live subtitles will be generated for that video, and it will be shown to the person to whom the video call is done. The unique value proposition that we are adding is that the device has customizable vibration patterns for various events. So suppose it is an emergency event, then it would it will vibrate in some pattern. If it is a call for a meeting, then it would vibrate in some another pattern, etc. Another unique value proposition is that video and audio stream shall also be encrypted. So apart from the data, the video and audio stream would also be encrypted to ensure the data privacy and the safety. So the next part, it is a brief on how WebRTC is used. So hello there, this is Parth and I would be focusing on the WebRTC and the YOLO part of our solution. So in our solution, we have used WebRTC, which is a real-time communication framework, because it's the perfect framework for handling peer-to-peer communication. To make this system more accessible to the deaf community, we have also integrated YOLO. YOLO is basically a deep learning algorithm, which means you only look once, which is used for interpreting the hand gestures of the deaf people into text, and that is being subtitled in the video along with. So let's take a look at the code. So this is the server code. This code is basically used for hosting a server on my local machine, and this is the app.py code. This code is used for running the YOLO model on my camera input, and this is the index.html file, which is basically the UI with the client code being embedded in it. So let's see how to do it. So we'll first start the server. Okay, so the server is started. Now what we can do is that we can go to the local host, and so we can see that the camera has started, and we can end the call also. Currently the audio is muted. You can see it here. Currently the audio is muted because it would create disturbance in the voice. Another thing that we will do is that PC, and we will run the Python app.py file. So it will take some time to run. Okay, so it has started running. Now let's check. So as you can see, this is now symbol. Okay, so this is the help symbol. Yes. So now to run this on a different device, what we have to do is we will open a new terminal. We have to enable port forwarding using ngrok. So ngrok http 300. Now I have to send this link to another device so that it can also join to the video call. Okay. So I have sent the link to my mobile device. Let's check. So as you can see that both the devices were joined, and yeah, so the WebRTC is working fine. Now you can just end the call. Browse all the services that are running in background. Okay, so let's get a technical review of what we have done. So whenever a user signs during the video call, the camera captures the frame in our Flask-based backend. So this we have utilized a Flask as our backend for Python service, processes them through YOLO model. The detected signs are then labeled and shown below the video. Okay, and can be understood by the person who is non-deaf basically by reading the text. So yeah, this is it. So the another part, which is basically how we would integrate this WebRTC and YOLO service with Raspberry Pi, will be explained by my colleague Anshul. So Anshul, over to you. Thank you.
For the hardware implementation of our video call intercom system, we have used a Raspberry Pi as the intercom module. The Raspberry Pi was chosen because it's compact, affordable, and powerful enough to handle both our video streaming and the ML model. We are using IP webcam instead of Pi camera because of hardware limitation. To get the video from the IP webcam, we are using a script. Here's the script. For now, in this script, we have hard-coded the IP address and the port of our IP webcam. So, when we log in into the Raspberry Pi and when the IP webcam server is active, the script will automatically run and fetch the video from the IP webcam. Let's check if it works or not. So as you can see, just as I logged into the Raspberry Pi, the IP webcam has automatically started. We will use this video as an input for the video call